And then, I got another little review to look at too. Well, let's see what we can get going here with this one. This doesn't look too bad. Let's do question 1 first. Just shout out some answers here. What's the degree of this polynomial? 4. Yep, I heard somebody over there counting. Exactly. We have 1x here, we have 2 here, and 1 here. So if we were gonna FOIL this all out, which we are not, but if we were, we would end up with x to the 4th. That would be our degree. Now, what's the leading coefficient? Again, think about it. If you FOILed it all out, what would be the number attached to that x to the 4th? 1. Leading coefficient's 1. So, in behavior, you should now be able to, we got the positive one first here. You should be able to do the end behavior because you have figured out that the degree of the polynomial is even and the leading coefficient is positive. So what does that look like? Even degree, positive coefficient, that is up, yep. So these are both going to be positives. So far, easy enough. Y-intercept. Okay, now wait a second. How do we find a y-intercept? We should not be perplexed.
You put in 0.
Exactly. Kids, isn't a y-intercept somewhere on here? So I'm just randomly gonna put it right there. What do I know about that point? I have no idea if that's in the right spot or not, but what do I know about it 100%? X is 0. So I'm gonna come up here and I'm gonna plug in 0 for all my x's. So what am I going to get? 3 times, this is all multiply, times 1 times -4. So I've got it in the wrong spot. It's actually down here, 0, -12. Would you agree? Okay. I'm actually, down at the bottom, they want you to graph it, so I'm gonna go ahead and just start my graph. So I'm down here at 0, -12. Okay. What are my zeros and what is their multiplicity? Well, my zeros are -3, +1, and +4. Would everybody agree with that? And what are their multiplicities? Well, these guys are just what we call simple zeros or single zeros. They only have, they only occur once. But that one has a multiplicity of 2, which means at these 2 points, the curve, whichever way it's going, is going to go straight through. But at this guy, he is going to bounce off. All right. Find one other ordered pair on the graph. I don't know why they're having you do this, but okay, let's find one other ordered pair. How would we find one other ordered pair? What would we do? Plug in a number, right? So what do you want to put in? What would be easy? Can't put in any ones we've already done. So 2. So what happens if we put in 2? Just a random number. If I put in 2, I'm going to get 5 times 1 times -2. If I put in 2, so 2 gives me -10. And again, I have no idea why they're suggesting we do that. We don't need it because we've already figured out that the curve starts up here. That's its end behavior. Has to grab that point, bounces off that one. It's going to grab that point and head up like that. We have no way of knowing how far down this goes. I just turned it around right here, but it might go down farther. We don't know that. I don't know where that is, how much farther down that is. Doesn't matter, we're just doing a general sketch. That's it. You okay with that? Okay, with your teammate, go ahead and sketch the next one. You can leave off that question that says find one other ordered pair on the graph. Just leave that off, we don't need it. But go ahead, you and your teammate answer all the rest of the questions and do a little sketch for question 2.
But oh wait,
Oh, right, yeah, the left.
well, I'm used to seeing it left first.
Do you agree with 3, 0?
Okay, how are we progressing here, folks? Does your picture look kind of like mine? It won't look exact, but is it generally speaking like that? Did you see there's only one real 0, so there's only one?
Is the X squared before that?
Those are gonna give you imaginary roots, yep. If you solve that, you get plus or minus 2i. See that happened? Yep. So the cubic polynomial does have 3 zeros. It just so happens 2 of them are imaginary this time. Right? Will we ever have all 3 be imaginary? No. Because what do we know about imaginary roots? They come in pairs. You can have 2 of them, you can have 4 of them, but you can't have 3 of them. And doesn't that make sense when you think about what odd degree polynomials look like? Don't they always have to cross at least once? Because they have to get from up here to down here or vice versa. So they're always going to cross. Now, even degree polynomials do not have to cross anywhere. They can have all their roots imaginary, but not this one. We good? All right, turn it over. Question 3, now you don't have an equation, all you have is the picture. So where's the y-intercept in number 3?
0, -10.
0, -10. Okay, that's easy. How about zeros? What zeros? Another name for zeros is x-intercepts. Where are they? -2, 0, and 5, 0. And -2, 0 has a multiplicity of 2 because the curve bounces off there. In behavior, the limit as x approaches infinity, that means to the right. What's happening to our picture? Up, so positive infinity. And to the left, down, negative infinity. Perfect. What's the degree of this polynomial? 3. Could we find the leading coefficient? Tell me what you know about the function already. Already we know that it has x plus 2 and that one squared. And we have x minus 5. Right? The leading coefficient, I'll just call it A. I don't know much about it except that it is positive. Would you agree? Okay. Now I also know that the point 0, -10 is on the curve. So if I put zeros in for all of my x's, I have to get -10 back out. Would you agree with that? So I think I can solve this. I think I can figure out where that number has to be. I think that number is 1/2. What do you think? So how did I find my leading coefficient? I built the framework of my function based on the zeros, and then I plugged in the y-intercept, and that gave me my leading coefficient. So this, here's my equation. So what is the equation for g of x in intercept form? Right there it is. Intercept form means factored form, because what do these factors give me? The x-intercepts. Then I'm not sure why this would be a challenge, but it says, what would it be in standard form? What do you think we have to do if we want it in standard form? Multiply it out. So that's a FOIL, don't forget. So this would be standard form. I'm not done yet, but you know, this is the factored form. And this frankly is usually good enough, but we'll practice this one time to get it in standard form. So I FOILed this out. Now, you remember how to multiply these two together? It's just a big giant FOIL, right? So it's gonna be x cubed minus 5x squared, 4x squared minus 20x, 4x minus 20. So just make sure, whatever order you want to do it is not important, but make sure each of these is getting times by both of these. So I took x squared times both of them, and then I took 4x times both of them, and then I took 4 times both of them, but you can do it however you want. Collect like terms. And distribute the 1/2. So 1/2 x cubed minus 1/2 x squared minus 8x minus 10. That is your standard form of your polynomial. Everybody okay with that? We haven't done any of that. Everybody good? All right, try the second one with your partner. Question 4. You don't have to multiply this one out. Just leave it in its intercept form.
Oh, negative 12, okay.
Yep.
Does the fact, my leading coefficient came out to be -1, is that what you got? Does that make sense in terms of the picture and everything? Do all the pieces fit together? Yeah, because it's an even degree polynomial and it's down, that means its coefficient, leading coefficient has to be this. Everybody, okay? Good. If we did, I really don't wanna take our class time to multiply this out. We're actually gonna learn later on in this chapter a shortcut way of multiplying that out if you don't already know. So I'm not gonna take the time to do it now. But if we did, everybody understands that means x plus 1 times x plus 1 times x plus 1. So it would be a giant amount of foiling, and then you would still have to multiply in the x minus 2, right? All right, so now, you put all that away. I've got another practice sheet for you that I kind of put together. You need to get your calculators out, and a little bit of calculator work to start. And then, I realized after I had run this off that I forgot that page. So if we get to that far, I'll just have to put it on the board. We may not get that far. This is a pretty big sheet. And it says 1416, but it really is over everything. There's a little bit of everything on here. So let's work through this as best we can. So we're using our calculator to do these first couple of problems. And we're going to find the relative max and the relative min of this polynomial. You know, without us even beginning, that since there are no restrictions on the domain here, it doesn't say, you know, x is between this and this. This is a cubic polynomial, so how high is it going to go? Infinite. How low is it going to go? Infinite. So there's no absolute or global max and min, but there will be a relative one. So go ahead, while I'm getting this thing copied down, go ahead and see if you can find those 2 points. Take whatever window adjustments you need to make. If you do, I don't know what this looks like, so I have no idea, but if you need to make adjustments, make them. Try to make the numbers easy to type in. Does everybody remember how to find maxes and mins? We use our second trace menu, it's a calc menu. So second calc, pick whichever one you're doing, max or min. Then you want a left bound and a right bound surrounding the point you're looking for. So my picture looks something like this. This. So if I'm looking for my maximum, I'm going to set a right and a left. So surrounding that point right there. And it says the relative max at x equals, anybody got it? X equals something? Not yet? Okay,
Negative
0.245. Yep, that's what I got. And I haven't done my min yet. Have you already done the min too? I got that one. Where do you have that one? X equals 717. Yep, 0.717. Let's round it to 1,000. 0.717. Perfect. Okay. Now let's look at the next one. Now be careful. What's this question talking about? How do we know where we change from increasing to decreasing? Think about this picture right here. If you're changing from increasing to decreasing, aren't we looking for maximum? Isn't that what happens at a maximum? So question 2 is just the same as question 1, it's just worded differently. You're finding a maximum. I don't know if this happened to you. I've got an old calculator and it sometimes does this sort of funky thing. Anybody find a maximum and something kind of strange came up? Yeah. So what came up on mine was negative 1.279 e negative 6. Anybody else get something that looks like that? Now, let's keep in mind, this is scientific notation. That's what that is. So negative 1.279 times 10 to the negative 6. What kind of a number is times 10 to the negative 6? Very, very small. Would you agree? Anytime this happens, you're going to interpret it as 0. Because if you went to round that off, it's going to be 0 anyway, isn't it? 0.0000. Because everything the calculator does is logarithmic, it doesn't do any calculation the way like normal people do. It does everything with logarithms. There's sometimes some round off error built in there, and that's what's popping up right here. That will happen occasionally on your calculator. So be on the lookout when you see this, it's 0. And sometimes it's negative 11, sometimes it's negative 13, it's negative something. All right. Then it says changes from decreasing to increasing. Isn't that a minimum? Okay, so now we're gonna find, I think there's 2 of them. Would you agree? Hopefully they are normal. Negative 0.598, does that sound like one of them for you? that make sense? Can somebody talk about how this makes sense, sort of? What shape is this thing? It's even, which means it's symmetric across the y-axis. Look at your equation. I know the numbers are very strange. If you plug in a positive number for x or a negative number for x, as long as it's the same number, won't the output be the same? Yeah. That's a W. It's a good old W. All right, good deal. Put the calculator away then. Anybody have a question about the calculator part? Everybody can find maximums and minimums. And when it says something like changing from decreasing to increasing, we're going to think about what that means. That means find a minimum, right? Okay. All right. This function is blank at an blank rate. Fill in increasing or decreasing. So both blanks, we're going to fill in the word increasing or decreasing. So this function is increasing at an decreasing rate. How do we know that it's increasing? Going up. How do we know it's doing that at a decreasing rate? Concave down. Perfect. You people are brilliant. All right. Number 4. Could this be concave down? Explain. Let's see. It's the whole explain part that we really have to focus on. As I'm writing them down, I've got same size intervals over here. That's good. That's good. That means we can talk about just about anything. What are your thoughts on this? What should we do? Find the difference? Oh, now somebody said sketch it. Gotta be careful here because we just have points. We don't know really what's happening in between. But let's go ahead and do this kind of, it's not really algebraically, but like with numbers. What's the change here? Negative 12. What's the change here? Here. And here. Positive 6. Would you agree that the average rate of change is negative 12? For these 2 points. For these 2 points, it's also negative 12. For these 2, it's negative 6. The difference over here is 1, so I can talk about average rate of change. And this is positive 6. Where do you want to go from here? Keep finding the difference. All right, so what's the difference here? 0. And this one is positive 6, and this one is positive 12. You want to do one more? Okay. I'm not sure what I'm doing here. I'm just doing what you're telling me. So did I get those right? Okay, so tell me, what does this tell me? Okay, so Bryce says that because of that, and these 2 now match, whatever function this is describing, it was a 3rd degree. Okay? Does that help me? Well, I guess in sort of a offhand way it would, because what does a 3rd degree look like? Isn't a 3rd degree automatically going to have a concave and a concave down and a concave up? So I guess, could it be concave down? The entire function could be, for sure. If I put all this together, you know, the whole picture, this big x cubed thing. What about this part of it right here? What's your thought on that, Drew?
Couldn't we tell just because concave down slope, the slope has to be decreasing, and you can tell that the slope isn't decreasing.
Okay, so the rate of change is decreasing. So concave down is our question. And concave down means that the rate of change is decreasing. Isn't these our rate of changes right here? What is happening to our rate of changes? They are actually increasing, right? Or staying the same, or increasing. So is this section of the curve concave down? No. Now, I gotta be careful because Bryce, you were thinking, your thoughts were good, but we're only looking at this part of the picture. Certainly, once you determine that it was a cube, part of it is going to be concave down for sure. But in terms of rate of change, we want to look at those right there. How are those changing? Well, they're actually increasing, which would make that part of the picture concave up. All right, good, very good thinking. Okay, next page. Whole bunch of questions. Relative max at x equals what? 3, perfect. Relative min, my picture's a little sloppy, that when I connected those two, I was supposed to connect them there on the left. So I'm gonna have a relative min at 1, 2, negative 3. My picture's sloppy. And then I also have one at 1, 2, 3, 4, 5. So I have 2 of them. Everybody good? Negative 3 and 5. Absolute maximum, none. See those arrows? None. Absolute minimum, -3, where x is -3. Words that I could be using instead of relative and absolute are local and global. Make sure you're familiar with both of those. On which intervals is f of x increasing and concave up? So increasing and concave up would be where? -3 to 0. Anywhere else? 5 to infinity. 5 to infinity. Very good. So increasing and concave up. -3 to 0 and 5 to infinity. Does anybody have a question about that? On which intervals is the rate of change negative and increasing?
3 to 5.
So these are just different words for basically the same concept. What's rate of change? So we want to know, where is the picture going down? And at the same time, increasing, which means it's concave up. So where are we going down and concave up? I heard somebody say something.
3 to 5.
Oh wait, 3 to 5. 3 to 5, decreasing and concave up. Yep, 3 to 5, I would go with that. -9. Now, let's talk about that -9. See that arrow there? Yeah, maybe negative infinity to -3. If that had been a dot there, Oscar, we would say -9, but since it's kind of keep them going there. Is that okay with everybody? Did we get all the sections? Every part? All right. Solve this inequality. And I have been a little less than careful about this, so So I wanna make sure we're showing adequate work. So here's my number line, I'm definitely gonna use a number line. If I had my calculator, I could graph this thing and figure it out that way. I could probably even do it without, but I'm gonna use a number line. And where are my dots gonna go on the number line? There's gonna be 3 of them. Where are they gonna go? -2, 0, and 3. And I might as well go ahead and color those in because those dots are included because of the or equal to. Right? Now, if this is on an exam and I'm expected to show my work, then here is the work I'm going to show. I'm gonna pick a number out here, anywhere, I'll just start out here, like -3. And when I put in -3, this part right here is going to be positive. Would you agree with that? This will be negative, and this will be positive. So this is my sign chart that is showing what happens with any number that I put in here. Well, what happens when I multiply a positive, a negative, and a positive? Okay, that isn't what I want. This means I want positive, right? So I'm moving on. So maybe I go to -1. So -1 would make that positive, and that positive. Is that good? So I'm gonna shade that in. That counts. Now I'll move over here and maybe plug in 1. So negative, positive, positive. Nope. And then I'll plug in 4. Negative, positive, positive. So in this case, the only thing that actually works is the part between -2 and 0. Julia?
Why is this number line not alternating like the other ones?
Because of that right there. That always throws it off. If you have anything abnormal about the problem, and a squared factor would be an abnormality, it doesn't alternate. In addition, your knowledge of the alternating really doesn't qualify as shown work. So while it's good to have that in the back of your mind and know, oh hey, these are gonna alternate or not alternate, this would be the kind of work you want to show. All right, let's digest that for a second. Is that okay with everybody? Easy? All right, number 7 is the same kind of problem, except this time you are doing it from a graph. So if we want to find all the places where h of x is bigger than 0, remember, h of x is y. On your graph, where is y positive? Isn't it up here? So what are the x intervals that give me y values that are up here? Well, let's see. 1, 2, 3. Is this one over here at -4? This is awfully small for my old eyes. And I have one at 1. And then where's the other one? 1, 2, 3, 6. Do I have my zeros right? So any part of the curve that's above those dots. So this and this, I guess that's it. So what are we gonna say? What is going to be our answer?
-infinity to -4, -4.
Beautiful, I am so glad you split that. Why did he have to split it? Why didn't he just say everything from -infinity to 1? That's an open circle right there, yes, very good, these are all open circles. Beautiful, beautiful, beautiful. Any question about that? All right, write a possible equation for this curve. Well, we kind of did that a minute ago. Write a possible equation for this curve. So tell me what we know about it. What are its factors? X plus 5. Hope I'm counting right. X plus 1. And 1, 2, 3. X minus 3. Anything else I should be paying attention to?
No, you can read that X minus 3 squared.
This has gotta be squared. How do I know it's gotta be squared? Bounces off there, good. Now, since we have talked about this a little bit, I think we can come up with an actual equation for this. That's perfect. What is the only thing I don't know at this point? What's the only thing missing from the equation? Coefficient. Can we identify a point on the graph? Doesn't have to be the y-intercept. Does it look like the point 1, 2 is on this graph?
Yeah.
It's not marked, but the way I do it, it looks like 1, 2. So I'm gonna go ahead and put in 1s for all of my x's and 2 for y. You can use any point that you know on the graph, so any point you can identify, you can use. Did you get 1/24? So based on what we approximated there, that's the equation we came up with. Does that make sense? Should that A term, A coefficient, should that have been positive? Yeah. Everybody okay? Don't you dare act bored. Don't you dare. We gotta get this stuff down. Here we go, number 9. Find all the zeros and state their multiplicity. So simple. What are the zeros? 0, -2, and 6. 0 has a multiplicity 2. 6 has multiplicity 3. Elementary. Be a little bit more complicated. What do you probably think we're gonna need to do for B? Probably gonna have to do some factoring, so. X squared minus 16. Plus 4 minus 4, perfect. And how about x squared minus 8x plus 16? X minus 4, x minus 4, x minus 4 squared, perfect. So all together here, it looks like we got an x plus 4 and 3 x minus 4s. So our zeros are -4 and 4, and 4 has a multiplicity of 3. All right, go ahead and do C, same thing. Xander, what'd you come up with, y equals?
I got y equals x, and then I got x minus 5,
X minus 5,
and then x plus 5,
okay.
and then x plus 2 squared.
How do the rest of you feel again? Is you okay?
Good.
Perfect. So you said your zeros were 0, 5, negative 5, negative 2,
Yeah.
and negative 2 had multiplicity 2. Beautiful. Okay. Match the function with the end behaviors. Now, because each function has two ends, there's going to be 2 matches for each one. So, what are you thinking when you look at number 1? First thing you should be noticing is there's a negative coefficient on it. And what's its degree? I think it's 8. I think it's even, isn't it? 8. So negative, even is down, down. So you're gonna match with the negative. So it would be B and A, I guess, A and B. Those are the negatives. Would everybody agree with that? Easy. All right, let's look at the next one. That one you don't even have to multiply out. That one is odd, negative. Nope. Odd negative is actually up, down, isn't it? Starts up, ends down. So on the left, you're positive infinity, so that would be C. And on the right, you're negative infinity, so that would be B. So B and C for that one. Guys, are you with me? Up, down. That's what it looks like if you're a negative odd. Okay, what's 3? What's its degree? Even. What's its coefficient? Positive. Up, up, right? So that would be CD. And then how about 4? 4 is down, up. So on the left, it's gonna be down, so it's A. And on the right, it's gonna be up, so that is D. Julia?
For number 2, would the degree be even?
For number 2,
Yeah.
it's x cubed.
Okay. Oh, sorry.
Yeah, when you're looking at degree, you're looking at highest power. Okay? Julia? No? Got it? All right, 11, find the zeros. Okay, last one, let's get this one done. How are we gonna find the zeros of this guy? Without a calculator, I mean. Oh, factor by grouping. Guys, I want you to think about all like this right here. How did we know where the zeros were? Didn't the zeros come directly from the factors? So we gotta factor this thing. Unless we're gonna graph it on our calculator, we need to factor this. So Anna said, let's factor by grouping. Okay, well this is a skill you learned before, hopefully you remember. What has to happen if you're gonna factor by grouping? What must happen? You must get a match, right? Because now you're gonna factor out the match. And there we are. Yeah, yep, 2 of them are gonna be imaginary, but your job was to find them, so we're finding all of them. So one of them obviously is -4. And the other ones are going to be plus or minus I root 6. Remember, you're square rooting, so it's going to be the square root plus or minus I root 6. Everybody okay? Alright, let's finish the one on this page, and I promise this is the last one. Circle the true statements. Alright? B of X is increasing. B of X is decreasing. Yeah, so B is a true. The rate of change of B of X is increasing. Yep, yep. And then obviously the rate of change of B of X is decreasing, not true. So it's B and C. Okay? Alright, well, we'll finish this tomorrow. I'll also run off the final page that I forgot to run off. And then we'll probably start, the next section. And then our next class after that, we'll have to. Were you listening when I said, tomorrow we'll finish reviewing a little bit, we'll start section 1.7, and then our next class, whatever day that is, we will have a quiz over the stuff that we've been reviewing, okay? Huh?